And Mike, can you verify? Sounds like it's working. When I start popping out of my computer. Okay. Okay. Awesome. So just to start, everybody should have this Google Doc open. The link is the tiny URL over there. We'll use that same model. And again, this is live notes for everybody. So please, anything that pops up, if you have questions, type them in there so we can look back through this and address them. We're going to start using something called live code today. And because that can get kind of crazy, because I'm going to try to make my screen really big so you all can see it. Sometimes things start flashing by and you don't get a chance to see what just happened. And in order to save you the trauma that can go from like, wait, I didn't see what was entered, we have created this link right here. Everybody goes to that link, and if you just click on it, 1 million clicks. What you're going to see is this blank document right now. Okay. But what's cool is you can just copy and paste this and refresh this as we go, and it's alive. It's linked. Basically, Mike and I have our computers linked to this script on Dropbox. So every time we save, it'll show up in here. Okay. So you can just keep this tab open, and you can always refer to it. It will always be up. It's never going anywhere. So after the class is over, you can always go back to this and see exactly. And we will try to be diligent about putting everything we do in here, okay? And commenting it and stuff. So let me, as an example, let me open that up. So I'm going to open up my RStudio here. And you'll see I have two scripts, one from last week, which we didn't use, duly noted. And then this week's. And this is the same code. Let me make this bigger. Is that big enough, folks in the back? Can you see that okay? Yeah? Okay. So now let's say, okay, first part of class, overview, git, save. Now let's go back over to our live code. Refresh. Voila, there you go. Okay, so that's how that works. So we'll have the code here. You can check it out. This will also live in a GitHub repository that you can check out too. But that's live code. Any questions about live code and what that entails? No? Okay, cool. So this is definitely something like I would just, keep this open or bookmark it, whatever you want to do. We'll have one probably script each week that we'll do this same thing with. And then let's go back to our document. What else do we need today? The class website, we'll definitely be using the site. Today we're going to be going over a little bit of the Git and the project management and spreadsheets, which I know people are like, spreadsheets? I use spreadsheets. I don't know spreadsheets. Well, that's exactly why we're going to talk about it. Because at some point, if you haven't experienced pain with spreadsheets, bless your soul. I don't know how to do it. So anyway, that is something I think that's really important to go over. And so we'll talk about that in just some ways. I mean, we're all going to end up using spreadsheets. That's the reality. And so we're not here to sort of say R is the only way. Kind of is, but you're going to have to work with both, right? So if you're going to work with people that are working with spreadsheets, how can we do that in a way that makes your life and others' lives easier? And then we'll do vectors and data types. Okay. One last bit is the GitHub organization. Okay. One other thing. Let's all go to our GitHub organization, which if you try to navigate to that, if you click on the little cat silhouette over here on the over right, that's an easy way to open that up. This brings you to the repository where this website lives. And then if you click on the UCD, that will take you back out to the main organization, okay? One of the things, and a few of you have used, but I really want to strongly going forward recommend the discussion repository that's front and center here. You click on that, right now you'll see our live coding links. We'll keep these up here so you can always find stuff, and our Google Docs, okay? So it's another place to find this stuff. At the same time, we have this little tab that I mentioned last week called Issues. And each repository, no matter what repository it is, will have an Issues tab. What I want to do is use just this discussion issues as our sort of place where we file questions, comments, concerns. And one of the things that has been popping up for some folks on Macs in particular is this: when you clone a repository, you get this kind of weird error message. So Emily kindly sent these screenshots to me, and we pasted these in here and said, like, hey, this is an issue, and here's some potential solutions, which turns out they weren't actually sufficient, because Risa tried and was like, no. And then I was like, okay, let me be better about actually writing down exactly what you should do. And I think that was helpful. But this is a great, so now I could go over here potentially and close this issue for the second time. And so now it says it's closed. So if I scroll back up to the top where the little Issues tab is, you'll notice when we click on it, now it says 0 issues that are outstanding that haven't been answered. But this is a great place for you guys to have discussion. Anything that pops up, please put it in here, because future classes can use this, you can use this. And instead of, I want us to use this because last year we sort of used it, and so there's actually a lot of issues. You'll see there's 28 closed issues. And if I click on that, you can, the other cool thing is you can type in a word and it'll filter to if that shows up. So somebody else may have had your same problem. But one of the things that was happening is some folks would email me, just me, a question, and then I'd write a response, right? And that was great, solved their problem, but maybe somebody else in the class had the same problem. And then they email me, and then I have to go find my response and type up the response and send them. This way, it's all here, right? And everybody can see it, and future classes can see it. So it sort of becomes like a little library of things that we can solve, hopefully. So that's the discussion repository location.
Right.
Yes?
If we want to like reopen it, or can you just click that?
Right, so any of these, whoops, sorry, any of these, so let's say error message when trying to push data. So if I click on that, it'll bring up the whole conversation and you can take a look. Okay. And the cool thing is these are really flexible. So if you wanted to reopen one of these, we can certainly do that. And you all have the ability to comment, reopen, do whatever you want in here because you're part of the class. Okay. All right. Any questions on all of that? No? Awesome. All right, so now let's revisit Git. We talked a little bit about it, and I know first week is always crazy, people trying to get stuff set up. We've kind of already mentioned why Git is useful, but I wanted to explain again in a little more detail exactly what is happening, and then walk through just let's add a file on our GitHub project. So everybody, I would like you to open up, if you haven't already, open up your repository. It's your README, your repository that we created last week as our project. So open your RStudio, open that up. You should have a README in there in your main folder. Okay, so it should look sort of like this without these folders. You probably have to git ignore and an R project file or a README file. Okay. All right. So once that's up, I'm gonna draw on the board, which I know doesn't help folks who are when we're screencasting, but so Git. So what is Git? Git lives up here, or let's call this GitHub. Okay. And then this is your computer down here. So Dropbox, what does Dropbox do when it just constantly syncs up, right? Like every few seconds it's saving everything and looking for differences, right? That's cool, but the nice thing, or the downside of that is you can only go back so far in time and see what has changed and revert. The other thing is it's a lot harder to see exactly what version you want, right? How many have actually gone back to like use Dropbox or Box like to find a previous version of something, of some file? Have you ever used that option? A few people? Okay. It is one of the cool things you can do. You can actually go online and look for previous copies of stuff that you have. Problem is, it's just a name, right? If you don't know at what point something, unless you really just did it, what happened. So if we think like we're going back in time for different files, here's time. Each of these, versions of something, and you want to go back, you may not know which one you want, right? Enter GitHub. So GitHub is a nice way. So every time you are adding a file and making a change to a file, and every time you edit that file, so let's say git add, and then a file. I'm just going to put parentheses here that they don't get included, but this is like, actually, let's not do that. Let's just, no. Okay. So the cool thing about GitHub is you get to pick what you want to save in time. And you may not want to save all your files. You only want to save the ones the script you want, right? So this is your script. So when you do git add filing, what you're doing over here is you're actually clicking on the Git tab. Where is it? Here it is. Here's my Git tab. So for example, now I have this thing that shows up because I made this edit. So sometimes nothing will show up until you save the file. So if I click on this, that button, that's exactly git add, right? You just click the button, git add. That's that command. Okay? So that's the first step. The next step is what some of you have already done is git commit. So now this is your sort of message to yourself. So this is where commit messages become really important. And there's some great websites on like git commit histories where you can actually see all your git commits. So it's like a Star Wars scrolling thing. It's pretty entertaining because sometimes you can see where you are in a project when there's more profanity and things sort of ending up in your commit messages. That's fine, but I would highly recommend keep it concise, but keep it informative, right? This is your message to yourself saying, this is what this is what I did, or these are the changes I made, so that a year from now, when you're trying to go back in time, you can see a commit message and be like, oh yeah, that's right there. Or you can at least narrow it down to a few, right? So git commit -m. So what you'll see, these are called flags or arguments. We're talking bash command lines, this language we're using right now. Anything with a little hyphen or even two hyphens is usually like an additional argument. In this case, M means message. So we're just saying commit message. And then quoted, it has to be quoted. Let's say we add our script. W2. So I know it's week 2. Okay? So that's what I would do. Okay? So let's do that over here. So we've seen how to do this with so to commit, how would I do that in RStudio? Basically do that same message. How do I do that? Feel free. Anybody? Yeah. Press the commit button. Right. And then what do? Type in, I don't have to quote it in here, nice, thankfully. But what did I say? Add new script for week 2. And then I'm going to click the commit button. There you go. And it's going to say 1 file change, 3 insertions, and 1 deletion. So it actually will tell me exactly what is different and what I've done. So I can close that. Okay, cool. So now what do you think? What should we do? Push it. Push. Right. Now there's different theories on this. You can do a bunch of commits. So let's imagine I'm going to hold the pen in my hand. Let's imagine hopefully people can sort of see this. So let's imagine this is the starting point, right? This is the start of your project. And now you've made a change. And here's your commit. Each of these commits behind the scenes has a little hashtag, a unique identifier, so you can always go back to it. So there's our commit. Okay, here's our original. This is often what you'll see written as origin/master, which just means that's up on the cloud on GitHub. And let's say we want to make another commit over here. So we make another change to some file. Here's commit, another commit. Okay, we could push all of these, so both of these all at once. Let's use a different color. Back to our. Well, actually, what's going to happen is when we push, we're catching this point in time up to this point in time, right? So this is push, and now this is fast forwarded to this point in time. Okay, but you can. The cool thing is you can go back to any of these points that you want along that line. So you can make. My point is you can make a lot of different commits and then push them all at once. Or if you want to do a commit and push each time, you can do that too. The same exact thing. Okay. All right. So let's look at. So we just did that. So let's push this. So now I'm going to click the little push button on the upper right. Good, git push origin. So it's giving me the exact code. That's exactly, basically you can just type git push, and it's going to default to that. So now it says to github.com, to this repository, boom, boom. There it's done. Okay, it worked. Some of you might get some other interesting messages. We'll talk about that in a minute. So that's how you do it in our studio, right? So I want everybody. So now let's do it with the command line way, because the only thing I haven't added here is the git push command. This is like 1, 2, git push 3. The cool thing about git is that there's not that many commands for git. The bad thing is it's still very foreign and difficult sometimes. So I'm going to close this. Now we're going to use something we haven't talked about in our studio, but which is really cool and handy and might save some pain, hopefully. A lot of you may already have this little terminal tab up here. So if not, you go to Tools and Terminal, New Terminal. And it should open a window. I'd like everybody to have a green sticky up if you have a terminal window available. We will assess. Yeah. So you have that green sticky. There's one red, a couple. Yes, so you need the most updated version of RStudio. RStudio, yeah, something like that. Alternatively, you can just open a terminal window if you're on Mac and follow along. Okay, so if everybody has a terminal window open, or terminal open, I see only a couple of speakers left. All right, pause. All right. Yeah, so Yes. All right. Okay, so cool. So there's a few things because we're working with different some different platforms. Some of you might be on a terminal window that's separate of the RStudio. That's fine. This will still work, whether you're on Windows or Mac or Linux. Doesn't matter. The only caveat to that is the terminal window that opens. If you're in RStudio, the terminal window opened in the repository, in the project that we're in, which is nice. You see the path here says Dropbox already in the slide code. So I'm already located where I want to be. So if everybody types PWD for present working directory and hits enter, you should hopefully see a path that reflects where you are. Now, for those who are in RStudio, this should be the project or RStudio project. For those of you that are not in RStudio, you just have a terminal window. Now what we need to do is actually change directory to our project. Okay? So to do that, we need to do CD, which is change directory. Here's the really cool thing about command line and terminal, autocomplete. Okay, so if I use tab, so tilde is basically like your home directory, and so for most of you, you've put your GitHub R project somewhere in that vicinity. So tilde slash. Now if I type D R, now I'm already where I need to be, so I'm just kind of showing this, but I hit tab right there, and it auto-completed Dropbox for me. So whatever the first, you literally only have to type the first few letters and then hit tab, and it should auto-complete. If not, that's a really good cue that you are not in the right place or the path is different than what you're typing. Okay, it should auto-complete for you. So what you need to do is find where, if your stuff is in documents or wherever it is, you need to find that path and then type in as best you can a few letters from it, and then I'm gonna hit tab again. There you go, it auto-completed. Okay, and then I'm gonna hit enter. And I'm already there, but now it would have if I was not. So let me show that again. So let's try CD just tilde, which is basically now that's taking me back to my home directory. You know, we're all users on our computer. And so one of the things you can do to check to see, like, where are you? Remember, PWD, present working directory. Enter. So now I'm here, users or MP. Well, cool. I don't remember where my folders of stuff are. So another command, a new bash command, ls, which is list, that lists the files where you are. And if I hit enter, so I type ls, now you'll see, here's all of my folders. Thank you, Taylor. We'll add this to the script, or hopefully people put it in the Google Doc too. But now we can see, here's my different folders. One of the things that I want people to pay attention to as we go forward, and this is a sort of a data organization thing, look at the folders that have spaces. They are important to pay attention to versus ones that don't, because if I try to go into, so now I'm going to change directory to my box sync. If I type box sync like that, I'm hitting tab, nothing's happening. Well, let me try that. Nope, no such file or directory. Okay, well, looks like there's a space in there, right? So let's try a space, box space sync. Nope, that didn't work. Uh-oh, okay. CD box, now I'm gonna hit tab. See what it did? So a space counts as a sort of a special character in bash command line, and you have to keep it, sort of tell the computer there's a space coming with this backslash. So anytime you have a space or any other special character, you're going to end up having these slashes, backslashes. So Don't use spaces in your file names, your folder names, anything that you can. Use underscores. You can use, it's called camel case, where it's like initial caps. Anything like that, you can just put it all into one. It makes autocomplete much easier and just working with this sort of thing much easier. Okay, so I'm gonna go back to my Dropbox, which is where my file, where this thing lives. Davis, there we go, I hit autocomplete and it got me there. Okay, so green stickies up if you are now in your art project in your path. So if not, put a pink sticky up. Oh,
So, you're going to where this file
to this folder. Yep. So you're going to it, yeah. And then so another thing yeah. Yes. Yep. It's all good. All right, sweet. Okay, so if you're waiting, why don't you go ahead, let's create a new script in your RStudio and call it week 2 if you haven't already. So go to File, New File, Art Script. And this will open up an untitled. Go ahead and type in, so in scripting, we use a £sign in front to just designate comments. Use comments early and often is the general rule. So let's type, week 2 code. And then save that. So the little floppy disk no longer. What's that term for things that don't actually represent what they icons like this? I forget what it is. There's a term for things that are no like data. You don't use this anymore. It still means save. Yes. So when you click save, now go ahead and enter the week 2. Okay, I'm not going to do this because I want to use this one that we have. Hit cancel, but I'd like you to do that. And then I would like everybody, so here's the other cool thing you can do. So make your script, and then I'd like everybody to make a data folder and a scripts folder. So on your file, you do this in file, you do it in your Find or Explorer window, view. But just create 2 new folders that are in this project called data and scripts. So, sorry, that's way down at the bottom. And I'd like you to put your scripts into that scripts folder. So the one we just made. So you can either click on the new folder here and do it this way, and then you can always click on any file with a little box over here, and then you can go to this little more and copy to or move. So if I wanted to move it to another folder, I'd click move, and then it gives me the option to put it, it's already in scripts, but I could move it back out of scripts. It's up to you. Okay? So when you have a data folder and a scripts folder and a new script in your scripts folder, green stickies up. Do you have a question? Yeah. We're gonna, yeah. Okay, so let's reconvene. I want to show something really quick here. If I want to open up where I am, so just to see this, so let's look at this folder. Okay, so there's some questions about, so you can do this in our studio, or you can just look at your folder. I want everybody to sort of recognize this is our project and everything lives in it, okay? So whenever we do stuff in a project, which is also a GitHub repository. So our repository and our project are the same thing. The R project file always lives at the main, sort of the head of the directory. And then anything below that is these folders and those files, okay? So hopefully at this point we have now our, oops, cancel.
Hey Ryan.
Yeah. Yes.
So last week we had a GitHub repository that said W01, indicating week 1.
Yep.
And so that was on GitHub.
Yep.
And then we made an R project, and it also started with W01.
Yep.
Those two things had the same name. So are we going to have 10 projects? So like one for each week?
No.
So are all of our projects for this entire class going to be named W01 because that was what we did?
So yeah, Mike and I had talked about that we're just experimenting with this sort of GitHub Classroom thing. For now, at least for the next few weeks, we're going to stay in the same repository. This week 01 on W01 blah 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 be your name. We're going to use that same repository, okay? Just to get comfortable doing stuff. Then we're going to probably in about 2 weeks, I'm going to create another repository with some data in it, and that will be named something different. And I probably won't use W again, but that was just an example, okay? So yes, great question. And we will be using different repos to get you in the habit of like cloning and starting. The good thing I want you to get comfortable with is you can totally delete this repository off your local computer. It still exists on GitHub, and you can always re-clone it. And the same thing, we can make as many of these repositories as we want. And I highly recommend Like, for example, even within a chapter, like a dissertation, I make a different repository for each chapter, but maybe I even want to make a repository that's just for like some analysis specific to that chapter. And that's its own project, its own repository. Like, keep things organized and separated. It's much easier than just putting it all into one giant thing, okay? That's a great question. Okay, so we have a folder now. We have a scripts folder, data folder, scripts folder, and a script in our scripts folder, right? Yes, okay. So now we're gonna actually do the commands on the command line, which is our, where's console, where's my terminal? Terminal, there we go. Just make a new one now, I've got a bunch of terminals, but okay. So one of the things that's really handy that I use all the time is a command called git status. Man, that's annoying, I'm sorry. The path is really long. Git status. So if we type that, nothing shows up. There. So right now it's telling me on branch master, your branch is up to date with origin master. Okay, so that means everything is synced up. Great. For some of you, you might see something different. So let me make a change to my script. So I'm going to say, go over git commands, save that. Whoops. This is what happens with running out of screen territory. No. Using git status. Okay. So now notice this pops up in my git tab on RStudio. But also I want folks to go over to your terminal, your command window, and type in that git status again. This is a great way to sort of check and see what is happening, either wrong or what the status of my repository is. So it's going to say my branch is up to date, but it says changes not staged for commit. And then in red, you should see a file, probably your new script file, right? That you just added. That means that this file has been modified and Git sees that and recognizes, hey, this is different than what's up on the cloud, right? But what we need to now do is essentially add that file. We want to push this up to GitHub, right? So what was the command to do that? Git add. Git add. Notice right down below it says no changes added to commit. Use git add or git commit. There's all these like little helpful messages. Here's the other part. Git add, you can add all your files all at once if you want. I'm not recommending that just because I think you have a lot more control over adding one file at a time and keeping track of what you're doing. So we're going to add specifically that script. So again, this is where the path is really important. So I'm going to say scripts and autocomplete. I hit tab. And I'm sorry, this is really hard to see. Let me move it up a little bit. And then the file name is 2018 in my case, but whatever your file name is, go ahead and start typing that. And then hit tab. Okay. Look what happened. In my case, I have two scripts that are called W01 and W02. Right? So I hit tab and it only went as far as it could because now there's two files that have the same, same to that point. Okay, cool. Well, I know it's two, but what if I didn't? What if I was like, I don't remember what file it is? If I hit tab really quickly, without changing my command, it actually printed the two files. Everything that ends with this, it printed both of these. It shows me. And so if you had like 20 files, it would print all those files, right? This is a really handy thing. If you're not sure, tab, and it'll just show you everything. Then notice the command is still here. It's ready to go. Now I can say, okay, well, 2. That's the one I want. So I'm going to hit 2, and then tab. And now I have my file that I want. Okay, now I'm going to hit enter. All right. So nothing really happened, but behind the scenes, let's look at git status again. Now we'll see that this has been changes to be committed, modified, and it's in green, which means this file has been added, which is the same as what we did down here when we clicked it, right? So at this point, we've only done the click the button. That's git add our file. Cool. All right, so let's do a git commit. Git commit. And we have to use the little flag, the little argument flag, -m. And now I have to add a quoted message. I'm going to say, quote, update live script for git. And it end quotes. Okay. Hit enter, and now you see this little message. It's going to say one file changed, here's the things you inserted and deleted, and here's part of your nice short git commit message. Notice this little number? That's that unique ID that you can use, right? If you ever want to go back that time, it will tell you what that is. You can look at it on GitHub later. Okay, so now we've done our commit. So now what's the next step? Push. So how do we do that? Git push. Enter. Here you go. Nope. Git push. Because it's already been added and committed, so everyone knows what has changed. Okay. So that's now the sound. So now you know how to do this in different ways, either in RStudio or in command line. Yeah. It still exists, so it's up to you. Like, if we wanted to add that, we certainly can. It's totally up to you. Git ignore is like gives you some flexibility about if you wanted to add all your files every time. So instead of git add a specific file, if you want to add everything all at once, you would hit period -a. That's basically add all the files in this period is short for like this directory. So that means everything. And then add a is like all. So all changes. So the git ignore would allow you to use this command, and then whatever you put in git ignore would then git ignore. Does that make sense? But you have to push the changes. You'd have to fix your git ignore and then push those changes up so that everything after that, it will ignore the one file that you don't want to push. And the first time you do, initially. Let me show you. So let's open our git ignore for those of you that have one of these. So here's a good example. So I'm gonna show you one of the things that often on a Mac will pop up is this little ds.ds_store file. It's just a reference. It's like a kind of a hidden file behind the scenes, but often when you're pushing files up to GitHub, sometimes it'll end up there, and you just want to ignore it. It doesn't do anything. You don't need it. So I've added it here. And let's say, so going forward, we've also added this ignore the Dropbox file because this is in Dropbox. So this is another like hidden file. Okay, well, I want to add that git ignore. So now I'm going to do this. Let's try this git period a -a. Now let's go and let's use our git status command again. Okay. It says nothing has. I didn't change anything. That's why. Let's. I need to make a change. Hang on. Okay, so let's just make a quick change. I'm gonna just type something in here. Ignore and save. Okay, so now go back and do our git. String space is fun. Git add dot -a. Okay, git status. There we go. Now it shows up. So now here it's added my git ignore. But if you did git.-a and any other files that haven't been added are all going to go and show up there. Yeah, Taylor.
So we can add some files, and then we can do git status, and we can see what's going on. And we've done all that, and now we're ready to put them on to GitHub. And then we keep getting this error message that there is conflicts between the two, and there's something going on there, and what's going on.
Perfect. Something I should have mentioned at the beginning before we did all of this stuff. So Mike and I kindly have screwed everybody over by going into all of your repositories and making one small change. We put an X into your README file saying checked by instructor. The point of that was we were going to start this whole thing by having you git pull, because in every case from now on, whenever you open RStudio or open your command line, I want you to git pull. Okay? The reason is you're going to any changes that are up there if you have a collaborator. For now, we're just going to treat it as that, but let's all git pull, which might rectify the situation. So git pull. This one is up to date, but a lot of you will probably see. So let's all do that. Go ahead and yeah. Really? File. Well, do you want to talk about that? So yeah. Okay. So pause. Sorry. I kind of got us off track. So let's say your collaborator made some changes over here. I'll say this to your git. Okay. Which is my mistake. We made a change, and I forgot to do this. So we might actually have to go through and just accept the merge concept, or I don't know. We can talk about that. So we made a change behind the scenes just this original. Okay. So that means on our little so let's say this is the original one, right? And we've made commits potentially. But actually the where this is now is here. Because mine has a change that we haven't added. Sorry, we can't down about this is where this is currently. We need to bring that back to our repository, our local location, and sync everything up. And to do that, this git pull. Okay, and git pull will basically make all these changes back. Having said that, what happens is all of you are probably getting something saying merge conflict. Right? Some of you might have that if you haven't pulled first. Because what we did potentially is modify our README file, right? You modified your README file somehow, and now what also happened is Mike and I modified your README file, and those two things are now in conflict. So this is called a merge conflict, which is really common. It's not a big deal. It happens. Have a pain. I wasn't hoping to do this today, but so what we can do is basically it will show you the file and ask like, hey, are you sure you want to merge these two things? And it allows you to edit that file line by line. In our case, we can essentially accept those changes because we changed a different component of the file. This is, think of track changes in Word, right? How many people have used track changes in Word? Most of them, or Google Docs, anything like that. You know, when your advisor or somebody says like, hey, make a change, and you can accept or reject that change. This is sort of the same idea, right? It's just a scarier console version of that, where it literally is a line by line option to look at those exact changes, and then accepts them. And when you accept them, it then merges and syncs everything up. So the version you have here and the version up on GitHub are the exact same. So, yeah, you sent me a question? Okay. Does that make sense to everybody? I apologize. So, quick question, generally. What should we, in order of time, we're an hour in, what do we want to do to make this most expedient? Do people feel we could ignore this for now and deal with this in a little bit and jump into the data sheets and RStudio stuff? Or we can deal with merge conflicts, which at some point you're all going to have to deal with. It's just early days to jump straight into that. I'm open, Taylor and Mike, What do you all think?
How long would it take to do?
Not that long. I mean, hopefully we can just accept it and move on. But so show of hands, how many people had a merge conflict? So about half the folks. Okay. So Mike and Taylor. Let's see what they think, and then we'll move forward.
Let's do a quick one where you resolve the merge conflicts the proper way, saying that the one that's on GitHub is the correct one, and you might have the one on your computer, so you just want the one that's on GitHub. Then you can deal with the other one later.
Okay, and which command are you thinking of doing? You want to show?
I'll show you.
Great.
So Ryan, this is only for the reading, right? This is for the-
What's that?
This is for the reading file, not this one.
Correct. Yeah. This is what you shouldn't have a merge conflict associated with your new script. It's most likely with your README file because you have a README version and the GitHub has a README version and they're different. So we just have to make that. Okay. So yeah. So really quick. If you have something that says like it's basically Vim or BI, what I would like everybody to do, and I'm gonna just write this down without it. Let's put it in the Google Doc. So if you're in a weird screen that you're not really sure what it is, that's probably Vim or BI. And to get out of that without changing anything, what you want to do is hit $Q $. Okay? You should see this on the bottom left of your screen. If you don't, you might need to hit escape. Until you see, and so when you start typing, you see a little $Q $, or exclamation point on the bottom. So you need to hit escape. And now hit No, just hit it doesn't that's just a way to exit out of Vim. So anybody else have that problem? Are you now back at the I would love everybody to be back at this. Okay, yeah. Yeah.
So doing it within terminal and manually, or not manually, on our studio.
Yeah. Yes, exactly. You can pick one. Right. Some of this is you might run into problems and you know kind of what the commands are going. So that's right. We're showing both. But yeah, you can just use our studio. Yeah. All right. So Taylor has kindly told us the correct command to get us out of this pain, hopefully, is get pull, and then we're going to tell it something specific. So we're pulling our changes, but we're also saying we don't want to deal with anything locally. We want to keep the good stuff off of GitHub. And at this point, we haven't really made any big changes, so that's okay. So we're going to say get pull. Is it hyphen rebase, and then origin master. Again, I'm sorry, my screen doesn't show that whole thing. So yeah, so go ahead and enter that, and then if you end up sort of put a green sticky up after you've done that, and let us know.
If we have to work on that, do you want us to
If you don't have merge conflict, don't do that. You're fine. Put a green sticky up. That's fine. It's not a big deal. Okay, green sticky stuff. Yeah. It'll just say already updates if you haven't.
And then
So try to see origin. Then you can go back.
Okay, and so then this one was just saying that. Okay, so should I? I don't really know. Okay, so this is fine then.
So let's try. Oh, okay. So if you haven't committed changes yet, go ahead and add a message and commit your changes first, because that sort of saves whatever you have, and then you may have to do the full rebase. It's not allowing if you have uncommitted changes. Does that make sense? So just go ahead and commit.
Yeah, try that.
So I think I was yeah.
You can also try it without the original answer. Now, yeah, so everything should be pushed just good. So it works for us with 1 with 2 hyphens and no origin master. Oh, that one? Okay. It also worked with 2 hyphens. It didn't work with 1 for some reason. I know. All right, so green stickies, if you are now able to like sync up and if you do git push or git pull and if nothing happens, that's a good sign. Like it says everything up to date. Yeah. Yes. Sweet. All right. Don't worry about it. Yeah. Okay, so we're mostly there. So I'm going to go ahead and walk through the last couple steps, and then we're going to switch over to Mike. So
push our changes.
Right. So the whole point of getting to this point was to push our new script up to GitHub, right? So if you've already done that, awesome, thank you. If not, I would like folks to go ahead and add, and you can do this either in RStudio or in the command line. Add your new R script, commit it, and then push it, and it should hopefully work. So green stickies up if you've already done that, or when it's done, go ahead and add your and then we're going to switch over to Mike, I think.
This is just like what we were supposed to do from last time. Or there was
No, this is a new
something-
script. We made a new script, right? A new fresh script and a data folder. Week 2, yeah.
Oh, okay. So
But-
we just push that up.
I
It's
have
not supposed to
your
say
branch
anything.
is working by two. But I can't save anything. So has everything been committed, but I need to push it. So I guess, yeah, great.
Undo.
Wait, sorry.
Yes, sorry. So to list what we would want to do, we would git add. And we can do git add our new script, right? I don't have one, but this is what you would do. You git add a new script, right? And then we would git commit with that hyphen M
Capitals head.
and new message.
Okay.
And then git push. Those are the 3 commands you basically need. Well, and git pull obviously would be the first one we should have started with. So if I were to write them all down, they're sort of here. Git add. Actually, let me put top of that. 0. That's
Quit. Okay. Yeah. Hit enter. Okay. Oh wait.
Git pull first, then git add to file,
Quit.
git commit with a message, and git push. Okay? Those are the 4, pretty much the 4 main and git status. Those are pretty much the 4 main commands, or 5 main commands that you will hopefully have to use in Git.
Say yes.
And again, I'm just showing this so you know that when you click on the button, what's happening behind the scenes, because sometimes
Tools.
the button doesn't work, right?
New terminal.
Okay.
So
Whew.
try this.
All right. Thanks for bearing with me, y'all.
Try that.
Correct. Yes. Git add. The file is not quoted. Yeah. Correct. So let me add to this document.
Okay, we can try this. Space hyphen space before the 2 hyphens. Space dot. Just, yeah, space and then dot.
Yes, another space. Oops.
Yeah.
Like that.
Yeah.
Yes.
Okay. Now try to get stamps.
Yeah, for some folks that works, and others, yeah. Yeah. Sometimes the arguments work with 1 or 2. Depends.
Okay. Behind for the password. Okay.
Yeah.
So this message here says that your branch is behind the origin master. Origin master is the moniker for the GitHub repository. So you can pull in that information. So try that.
So now I can pull.
Yeah. Try.
You added that? Thank you.
Okay. So try get status again. I like
That's
constantly
fine.
status because I'm nervous
Okay.
about making these sorts of
If
changes.
everybody has
Okay.
stickies up, green stickies.
Now you can go through
Now
the
I'm
process
up to
of doing git add with those files, and then git commit, and then git push. Put those down.
All right, so let's. I'm going to really quickly jump into the next
You're gonna
bit.
files individually. Or
Okay.
so you have to git add space and the file names.
So each one.
Okay.
Yeah.
So
All right.
Thank you.
Yeah. Sure. Good luck.
I'm going to set Mike up. He's going to switch over. I'm just going to show the folder, the diagram folders. So best practices for project organization, just really quickly, and then Mike's going to jump into the other stuff that we've got. So RStudio projects, we've already talked about how great they are. And then I want to show a diagram. You don't have to use this exact thing, but I found this model to work really, really well. For everything you bring in, all your data, whether it's spreadsheets or whatever it is, keep the raw version raw. Don't touch it, okay? You want to make a copy of that and then do stuff to it, great. But don't change the raw data. And a way to do that, to sort of force yourself, is I like to have a data folder, and anything in that data folder is just raw data. And I keep it in there for that reason. The nice thing is if I ever need to redo stuff, I can always go back and it's a copy of it is there, okay? Again, this all lives in my working directory, which is my R project, where that R project file lives, and where your Git root lives. Okay, so this is our R project. Data output is basically when I go and tidy up some data, do revisions, whatever it is. That's the revised data. Okay, and then sometimes documents or docs is handy. Figs or figures is also really handy, and then scripts. And literally, every project that I start, I create those folders in every single project. And maybe you ask me more if you're doing weird modeling, or you can customize it. But the nice thing is, I use the same. If you look at any of my GitHub repositories, you'll probably see these folders. And the great thing is that makes it easier for me to find stuff down the road. It also makes it easier for my collaborators if I zip something up and send it to them, and I just tell them exactly what I told you, they can find stuff really easily. And any future collaboration, it makes it really easy, okay? So my recommendation is find something that works for you. And if this is it, great. If not, that's fine too. But stick with it for every single project. Because if you can really kind of force yourself to have that structure and put things where they belong, you will avoid this sort of desktop madness where you have 1,000 folders and files on your desktop and you're like, I don't know where everything is. Like, just really try to stick to it. And so I think that working directory structure is a really important thing. So at this point, we've kind of already done this. We made a data folder and a scripts folder. And I'm going to sign off and let Mike take over. And I apologize for the exciting foray into Git merge. Okay.
Let's see if I can do this switching properly here.
Did you share your screen?
No, I'm going to get this up there, and then I will. Let me. Yeah, you should confirm that. Good reminder. Let me know if that's good. Okay, great. Okay. We're going to take the next 20 minutes or so and talk about data management. So good data analysis starts with good data management. And we mentioned this last week also, but I want to reemphasize these points. The reason that we're learning these tools is because they dovetail nicely with the tenets of good science, right? And so I've written some up on the board over here, and I think somebody has written them here on the Etherpad here, our shared documents, and nice use of the shared collaborative notes. Right, good tenets of science, pertinent. These kinds of tools are pertinent to your research, right? So if you're ever trying to convince yourself or convince your boss that taking the time and energy and frustration to learn through these tools, this is what I always go back to. So precise, I'm thinking of if we have a particular analysis that we want to address or a particular question that we want to ask, we want to be able to get right to that question without any sort of side effects that were unintended. When I talk about efficiency, I'm saying that computers are really good at doing data manipulation and data analysis, but we need to have our data and manage our data in a way that makes it easy for the computer to understand that data. When I say reproducible, I mean that we want to be able to start from the same place as everybody else and come to the same conclusions, whether we're following an analysis pipeline or making a figure or managing data. We need our data workflow to be reproducible. And then transparent is that we want that workflow to be apparent to anybody else, to be obvious to anybody else what steps we took to get there. And so those are kind of the four tenets of good science that we're going to talk about with data management, and then we're going to introduce R today also. So these tools are pertinent to good science. I just means ignore the rest of the letters. We're just going to talk about the first four. So spreadsheets, if you all could navigate to the website, the R. Davis website, and up here under course materials, I'm going to click on spreadsheets. Spreadsheets. And this is the lesson that we're going to be teaching from. So what I want everybody to do is to take this, is to go to setup up here. At the very top of that spreadsheets lesson. And these are some data that we're going to work with. So the first data set is going to be found at this project portal teaching database right here. So the data for this lesson, the workshop right here. If you click that link, it takes us to Figshare. This is a data set that's been used in a bunch of different papers. I think it describes small mammal communities across elevation gradients somewhere. There's some more information later on about exactly what these data are. And I want you to take this species.csv file right here. It says it's a data set, species.csv. And this little button here will download it. Download that file and put it in your data folder that we just created in your project. And red stickies up if you're having trouble finding that data or downloading it to your project. I want you to go ahead and double click it to open it. Oops. What's that?
Which files are we downloading?
Just the species.csv, this one right here. If I can find it. Okay, does everybody have this up? So a couple of principles that we want to follow, and Ryan just talked about some of these, so we're gonna, we're saying them twice, so they're important, right? So the raw data stays raw. Let's say that this is the original data that you collected. This is gonna stay this way. If you want to make changes to it, if you want to clean it, if you want to rearrange it, you're gonna make a copy of this spreadsheet and only make the changes to that copy. And skipping down to number 3, you also want to keep track changes of that copy. So what you can do is, for instance, to create another tab, like down here in Excel, I'm using Microsoft Excel, but there's a bunch of free software out there that you could use as well. You can make a whole new tab, and this can just be the sort of metadata for this particular for this data, the data about the data, where you can write down all of the changes that you're making in the sort of copied file. And then one other point that I want to highlight here is that these data are tidy, and that's a principle that we're going to talk about a lot in this class. So what I mean by tidy is that every single column represents a different variable, something that you measure, and then every single row is a different observation. So one row, one observation per row, one variable per column, and that's the sort of tidy data philosophy. Yeah. Not as a CSV. That's a good point. So that the second sheet would be, to sort of tether it in Microsoft Excel or something like that. Yeah. And this is what I do, and it's probably where what you will end up doing also is that you keep the CSV as a CSV, and you do the sort of track changes in R, right? So if it's possible to say you want to do the rearrangements or do the summarization or what have you, then your R script becomes that sort of track changes file, all the changes that you've made. So yeah, we're sort of thinking in terms of this is in a spreadsheet program, not as a CSV.
I would say something that I find helpful when I'm reading my data in R as well is like maybe you get your data from whatever your collaborator or your guys that have entered it in Excel. Save that as a .Excel file and then like copy paste the whole thing and save that as a CSV. So I've definitely had like times where it reads it as a text file and I have to like go through every column and there's like 3,000 rows. So always save it as an Excel file so you can always read it.
And that's a hugely important point, right? The raw data stays raw. However it was entered by the undergraduates, by you, whether you're in the field, that stays in that format. You can always make a copy of it, save that particular sheet as a CSV, or copy it over to a different file, or what have you. You essentially want to be able to go from that raw data and transparently show somebody else how you went from that raw data, that anchored raw data, and they should be able to follow all the steps that you followed to put the data in the format that you use to make your figure or do your analysis, what have you. Okay, so three sort of general principles. Raw data stays raw. Enter your data, or you want your data ultimately in a tidy format, one observation per row, one variable per column, and then keep track of the changes that you make. So what I want you all to do is now we're going to go back to this website. So this is back the spreadsheets website, right? So I got here by an hour, our Davis website, course materials, spreadsheets, up in setup. And I want you to download this messy data sheet to that data folder, to the data folder within your project. So there. It should look like. There it is. Look at this. Okay, so I want you to take 5 minutes and pair up with somebody else. I want you to start cleaning this data according to these kinds of principles, right? Make a copy of the data. Anytime you make an adjustment that you think puts this data in a better format in some way, make a comment somewhere in a text file as another tab on this spreadsheet somewhere. And then sort of start thinking about the kinds of changes that you think that this data set should go through in order to have it be tidy. So take 5 minutes to do that. And go ahead and put your green sticky note up if you think that you've entirely cleaned this data. But work with somebody else so that they can be typing the track changes and you can be making the adjustments. Great.
We have plots, and we make this a list of all our And just for the
Take another couple minutes.
First, put them all in one spreadsheet. Okay, so I'm going to say date selected. Plot. And you have empty cells. Yeah.
Okay, let's come back up front. So who finished cleaning the data? Okay, and earlier Ryan asked us who has gone through a painful process of working with data in a spreadsheet program. So who can now say that maybe they've gone through a painful process? Right. So if somebody wouldn't mind, this is the class notes up here. Oops, that's actually not the class notes. That's meeting notes. Somebody can pull up the collaborative class notes. We're going to walk through some of the changes that you all made. Can somebody add them into the Google Doc as we go? Let me pull that up. There it is. Okay, so what's one change that you all made? Nice, that's step one, right? Okay, so we took this data, this is our raw data, made a copy of it, and then we're working with the changes in the copy, right? That way we can always start from this anchor point of the original raw data sheet, follow that series of track changes to get to the kind of data that we want to work with in our analyses or figure making or what have you. Okay, what else? Yes? Species column, okay. And what was the sort of problem that you saw that species column would be good? Okay. So like the species. Right. Okay. So species is split up across multiple columns here, right? In tidy data, we want a single variable represented in one column, right? And we've got species in a couple of different places. So we've taken species and sort of consolidated it to a single column. Great. What else?
Field season.
Field season column. Is that and so what was the problem at that solved?
So you consolidate to
Nice. Yeah. So right now we've got this is a variable, right? The field season, which is something that you can measure or describe. So right now the field season is split up across two different tabs, and in tidy data world, we should have a column that represents the variable, right? So field season column, and then 2013 versus 2014 as the entries in that column. Great. What else?
This is a bit minor, but I find that it helps to have the format have the year first and then month and then day.
Yeah, and that's great. And in fact, so you're saying put the year for the date first, and then month, and then day, right? So that if you were to sort them, they would go correctly by when they occurred in time, right?
Yeah.
Yeah, and so that brings up another point too. That in Excel, who's dealt with sort of dates in Excel, where like you type in a date and then it becomes not that date, right? That's super frustrating, right? So let me show you a trick to deal with that, and I'll just put it in this other spreadsheet for now. So instead of having a date and putting it in as, like, say, even if we were to put it in as year, month, day, Excel might do something funny with it. So instead, if we break it apart as year, month, day, as three separate columns, we can always paste those back together another time, right? So this prevents Excel or whatever spreadsheet program from like or interpreting dates in its own particular way, and it, sort of maintains the integrity of that date's information.
Mostly means if you work with people.
That's yeah. You can put month or day in whichever order you like. Yeah. What else? How about
You need a notes column for the non-calibrated.
Yes. Which sheet was that on?
2014.
Okay, so here we have some data. Gray cells means measurement device wasn't calibrated. So these couple of measurements, the computer's not going to be able to understand information as Excel coloring, right? And so a separate notes column is a great idea. Calibrated or not might be another good column. Yeah.
Even if certain notes have a true false column for calibrated.
Sure, absolutely. Yeah, some way to convey this information that isn't in color, right? Because R doesn't understand Excel coloring. Yeah.
What if you want to have a notes column, you only have notes for some of your entries, and a bunch of the other notes, nothing.
Yeah, that brings up a really, really important point about missingness, right? What kind of entry in your spreadsheet denotes that that there wasn't any entry there, right? That the data there are missing. And there's a cool table. In fact, I think it's on this spreadsheets. Missingness, right? So here's a great table that sort of summarizes all of the issues with some cells being blank, some of them not. A lot of, like for instance, I work with a lot of government data, and they'll put in -999. It's like denotes, oh, there's no information for this particular cell, but that can be problematic because if you were to take the mean of that cell, well, now all of a sudden those integers are getting calculated along with that mean, right? So for R, and what tends to be safe even in Python and SQL, is to leave a cell blank, right? If you're entering data into a spreadsheet, if you leave it blank, R and Python and SQL will be able to interpret that as like an NA. It appropriately treats them as missing and not as like, 0 or -999 or what have you. Does that answer your question?
So it's okay.
Blank is good. Blank is preferable. Yeah.
So when you're doing a yes column, like the calibrated yes or no,
Mm-hmm.
I've done 0 and 1 before.
Okay.
Should you do blank and 5 yeses? Or
So that depends on your particular use case, right? I mean, if you checked and that instrument was not calibrated, it should get a no. And if you checked and that instrument was calibrated, it should get a yes. And if you didn't check, then you don't want to make that yes, right? So you would leave it blank. Yeah. So yeah, that's another key distinction of missingness versus, you know, sort of negative information. Okay, so I think we're sort of getting the idea here. On that spreadsheets lesson, if you know at your own leisure want to sort through the some of these other formatting problems, there's some good ones that maybe we weren't able to think of in the quick 5 minutes that we were able to go through this. Right, so recapping, raw data stays wrong. We made a copy of this data sheet in order to make the changes. We wrote down all of the different changes that we were making to keep track of them. And then the sort of tidy data philosophy is one observation per row and one variable per column. Okay, any questions about that? Okay, yes?
Yeah, I'm gonna go, where did you navigate to show the list of all of the types?
Right, sorry. So in the spreadsheets lesson from R. Davis, takes you to here, and then up here under episodes, there's a formatting problems.
So in real life, if someone would give us a data sheet, but it doesn't say there's no units for weight in 2014.
Yeah,
And
that
some
seems
2013.
It's like a problem,
2013 has like grams and then nothing.
right?
I mean, you wouldn't want to just combine those if you're not sure that they're using the same.
Yeah, no, that's true, right? You would want to check. And two, I would also point out that for this particular column, you're sort of mixing information, right? You've got the measurement 33 and then the units as grams all in the same cell. And I would separate those out or keep the grams as part of the weight, something like that. You want your computer to be able to interpret these data. And I guess that brings up another point too, is that, you know, there's no shame in organizing your data like this, right? If you're not into programming or what have you, this could be perfectly reasonable for you to think, okay, I'm gonna encode some data here as colors because hey, it really pops and that's fine. So there's no shame in any of it. What we're trying to move to is a system where we can emphasize those kinds of characteristics with our science, right? So no shame in having it done this way. We just want to try to improve it going forward. All right. You want to learn some R? Let's do that. Let's open up our studio. Ryan, is there anything we're missing about spreadsheets that you thought we should? Okay. And I'm going to work, hopefully, in that same art project that Ryan was working in. So let's test that for a moment here. Put this up here. So in scripts, week 2. Okay. If I say that, does everybody see that pop up when they refresh? Great. Okay, so just by way of reintroduction, this is our studio. It's the engine. It's our interface to R. And Ryan mentioned this also. If I put a pound sign before a line that I'm writing, R doesn't interpret that as code. It doesn't interpret that as an instruction. So you can write in a plain language, like plain English, what those lines of your code are doing. Okay. When we talk about programming, a program is a set of instructions for a computer to follow, right? So we write down those instructions and then we tell the computer to follow them. And this fits right with those principles also, right? The instructions that we write down are exactly what the computer is going to do, nothing more, nothing less. So we're precise. We're letting the computer do a bunch of work by giving it the instructions. So we're efficient, reproducible. We're reproducible because when we write down those set of instructions, somebody else can run that code and do exactly what we did. And we're transparent because that is the sum total of all of the instructions that we're telling the computer to follow. So this R script here, the simplest thing that we can do and is some math. So we can do 1 + 1. And with the cursor on that line, if I hold the command button and hit enter, that will now swap these. Send that information down here to the console where it has done that calculation for us. We can use scientific notation. 2e³ is 2000. I'm gonna move that up. Sorry, stand by. I'm gonna switch the console to be on the top so we can see that a little easier. Okay, so now the console's up here. Oh yeah, thank you. How's that? Okay. All right, I'm going to introduce you all to functions. So functions are a way of sort of saving typing time. Functions are sort of pre-written code. So for instance, if we were to call the log function of 1000 and then run that line, this is going to return the log of 1000, right? So when we're thinking about functions, think about 3 different things. What arguments do they take in? What do they do to those arguments? And then what do they return when they're done? So in the case of log, this value that we pass in, that we tell log to work with, that's called an argument. It's going to calculate, in this case, the natural logarithm as the default of that number, and then it's going to return a single numeric value that represents the result of that calculation. So we can nest functions. So think of functions with their 3-part summary. And what do they do to arguments? And what do they return? We can put functions inside of functions. Log of the g8 3 is going to return 3. And so it works from the inside out, right? It's exponentiating 3, e raised to the 3, and then takes the log of that. And we get back to 3. If you ever want to know what a function does, if you type the question mark before the name of the function and then run that line, it brings up down in this pane here some information about what that function does, the help file. And so log computes the logarithms by default natural logarithms. And it says log 10 computes the common, the base 10 logarithms. So that's a whole other function that would be computing the base 10 logarithms. One thing that I like to do with these functions, so tab complete also works in RStudio. So for instance, when I typed L and then hit tab, it brought up all the different possible things that start with L. If I were to type O, it's going to start bringing me all of these different functions. And one note I want to make about these arguments that you pass in is that you can name them. And so if we look over here in the help file, on this first line here, we see log open parentheses lowercase x comma base equals exp1. So these are two different arguments that the log function can take in. It takes in x, which and then it can take in a base. So we said that the default base was e, right? And the way that we would name these functions, or sorry, name these arguments is by using their name and then the equal sign. So we can say log 1000, let's go back to this, is same as log x equals 1000. So now we're being explicit about, we're saying 1000 is going to go into the sort of x part of that code. And then one other point here on in the help file, base is already equal to something, exp1, e raised to the 1. And that's suggesting that that's the default value. Right, so log is same as log x equals 1000, and base equals, if we just give it the same thing, and it's going to be returning the same value. But importantly, if we are naming these arguments that we're passing into the function, we can switch their order. So now we can say base equals exp1 and x equals 1000. R is going to interpret the arguments in the order that you give them if you don't put names. So this is not the same as log one 1000, right? So now it's asking for the logarithm where x is equal to e and the base is 1000. So we've swapped the order of them without naming the arguments. So this is why I always name my arguments, right? Because it makes it really clear what you're passing into that function. And then you can make the order interchangeable too. One thing I want to point out as I'm writing here is the white space in some of these code. So I've got log open parentheses x space equals space 1000 comma space. That white space all gets ignored in R. And so what I do is I use it to my advantage. I create visual structure in my code that makes it easier for me to read, and it makes it easier for other people to read it too. So two things that you can do. Your code should be littered with comments telling what a particular line is doing and why you're doing it. Maybe more importantly, why you're doing that particular line. And then use spacing and carriage returns and that sort of thing to create that visual structure. It'll be easier on your eyes. And there's a lot of sort of style guides for the best way to go about using that space. But for instance, when you're passing in names to arguments, keep the spaces around the equal signs. All right, maybe the last thing. Yeah, that's where we'll get. Okay. One of the most powerful things about R is that you can save information as objects and then manipulate that information later. So you can use it as a placeholder. And to do that, we use the assignment operator, which is a greater than sign, less than sign, sorry, and then a hyphen. Right, just like a little arrow pointing to the left. And so if we say A is assigned to 1000, and run that line, that nothing prints out like it did up here where it was printing out the actual calculation in R. So it succeeds silently, right? You have just successfully stored the number 1000 as the variable A. So I like to read that assignment operator as is assigned to B, right? A is assigned to be 1000. In order to retrieve the value stored in an R object, run, a line of code with just the object name. What I mean by that is A has been assigned to be 1000. If I just type A and run that, now we get back the value that's been assigned to that variable. Note too that variables can be reassigned. So A we just saw is 1000. We can reassign it to something else. Succeed silently, running that line again. Now we see that A's become 30. And it's going to go in order. So if it starts as 1000 and then the next line of code reassigns it to 30, it's going to take that last value that you've assigned it. Let's put up as our sort of final exercise for today. This question here. So what does the following code print? Let's make that bigger. So this is on the class website under course materials. Course materials, orientation to programming, R and RStudio. And then I believe it's down here in variables and assignments, and then it's just a little bit below that, just above variable name conventions. What is the following code? Right. To take 1 minute, see if you can figure that out. Is it option 1, A, lowercase a, option 2, 3, option 3, 4, option 4, nothing at all? What does the following code print? When you think you've got it, pair up with your neighbor and discuss why you think it is what you think. Okay, and everybody come back. So we'll do this informally. Who thinks it's option 1, it prints out lowercase a? Let's try this again. Everybody close your eyes. Raise your hand if you think it prints out lowercase a. Raise your hand if you think it prints out the number 3. Raise your hand if you think it prints out the number 4. Raise your hand if you think it prints out nothing at all. Great. Yeah, it prints out number 4. So we've assigned A to be 1, B to be 2. C is going to be A plus B. So A plus B is 3. C is now 3. B we've reassigned to be 4. It's no longer 2. C becomes A. C is assigned to be A, which had already been 4. And then when we write just the name of the variable, we print out 4. Good job. Yeah.
Just to be clear, if we hadn't previously assigned A to be 4, then it would be option 1.
Say that again. So which line do you want to modify or delete or? This one. So this wasn't here. C would become.
Well, just if sorry, take
That's
away
good.
all the lines at the bottom 2.
Just
right?
these 2. Yeah.
In that case, C would just be A. Is that correct?
C would be A.
Okay.
But
Because A.
we haven't defined what A is, and so it'll actually return an error. In our case, we had because we were writing code and said, oh, A is 1,000 and then A is 30. But
Unless you put A.
yeah, we're going to talk about that a little
So
bit more next time with sort of different kinds of data types that can be interpreted in R.
Cool.
Yeah. Okay. So let's. I'm going to put the link to the survey. In fact, I think it's already up there, asking about the pace of the class for today. One thing that worked well for you, and one thing that didn't. And if you could take 2 minutes and fill that out. Sorry for keeping you late. And we'll start right back in next week.
Should we commit our changes to this week 2 thing and push it?
I don't know.
Personal choice.
It's personal choice.
It's like you want all the data that we downloaded down.
Oh,
And those all get
right. That's not necessary. In fact, next week we might even be starting with a fresh.
So don't commit them.
Yeah, I mean you can if you like, and we'll just go back onto the cloud or see if it's okay now.
Right, but
I mean, typically,
we'll probably delete the next week. Or do something.
possibly if we go back to this project again.
Okay.
I'm trying it through here.
Are you okay?
Oh, and then I'm just
The
doing
push
it
and
for
pull
this, for
from-
the console order.
Yeah.
I know that
From our, okay, but the click button wasn't. I know.
But no, she has it. Yeah, this,
Yeah.
you pulled this up, we weren't able to do anything from our studio. We were
Oh,
doing everything
I just
from it.
reassigned it to the bin of the C. Cool. Yeah. Well, so I'll just put that in, and then I'm next.
I guess that's
I
what I
assume
would
they'll
probably
delete the next week. And once we delete the text, if they get told, then when they come in, they disappear.
Yeah, but I think they could also be recovered if they're still part of that. Right?
So,
Right.
but so,
So yes, they don't show up there. They are. You can recover them.
So just state all those data. Which the first page.
Yep.
Okay, right. And then once the CSV Excel file, you download it. Then submit them. Say, added data file.
I would say everything that's in there.
Right. And so sometimes like, I think we really finally saw that's why submit that because then it's always sort of part of it. Yeah, that's
I don't know how to do that yet.
I think it's like, but yeah, it's okay, no longer track that change. Type status.
is that really bad? We should be-
If you want to leave your name tags with us, you can. We'll just put them in the locker.